In problem number 1, we're going to graph the exponential function. My base is 2, which is more than 1, so I know this is going to be a growth. So I am going to plug in some easy points here. I am going to start with 0. When I plug in 0, I get 1, because anything to the 0 power is 1. So my first ordered pair is 0, 1. So right there on the graph. My next ordered pair, I'm going to plug in negative 1. So with negative 1, I end up with 1/2, because that negative 2 moves down to the denominator. So I get negative 1, 1/2. And I'm going to plug in positive 1. 2 to the first power is 2. So I got 1 and 2. And you can see this is exponential growth. Notice this graph doesn't go across the x-axis because that's the asymptote. In problem number 2, my base is 5, which is greater than 1, so this is going to be exponential growth. My a value is 3. That's going to be the y-intercept. So I'm going to start by plugging in 0. So when I plug in 0, I get 5 to the 0 power, which is 1 times 3 is 3. So that is my y-intercept. So I have 0, 3 right here in the graph. And then I do negative 1. The negative in the exponent changes this into the denominator. That's how I got 3/5. So negative 1, 3/5. Then I'm going to plug in 1, and I got 15. So I got 1, 15 way up here. And this forms an asymptote on the x-axis. It won't cross the x-axis. In problem number 3, we're going to use the exponential model that is going to be given on the quiz. So we have an initial value of 490 quail. We have a growth rate of 6%, so that's going to be 0.06. We have the time is 5 years, so I'm going to go ahead and plug that into the equation. So plug all my numbers into the equations, and then when you look at your answer, quail only come in whole numbers, so I am going to round it up. I am not going to round it down, so that's how many quail I get after 5 years. In problem number 4, we're changing from exponential to log form. My base is 7. So it is going to be log base 7. So that equals 49 is the value. 7 is the exponent. So make sure you check this to see if it makes sense. 7 squared is 49, which is correct. In problem number 5, we're going the other way around. We have a log. We're going to write it as an exponent. My base is 4. 4 to the negative 2 power is 1 over 16. 1 over 16, and that's correct because the negative means it goes in the denominator. So 1 over 4 squared is 1 over 16. In problem number 6, I'm going to evaluate. So my base is 7. 7 to the x power equals 1 over 49. I know it's got to be a negative because I have a fraction. So I'm going to factor 7. 49 goes 7 and 7. So now I have 7 to the x power equals 7 to the negative 2. That means x equals negative 2. And number 7, my base is 2. So I have 2 to the x power equals 64. I'm going to factor 64. 8 times 8 is 64, and 8 is 222. So I have the same basis, so all I do is read x equals 6. In problem 8, I am going to compare logs. So in this problem about earthquakes, I have an initial value here divided by another value. But I'm starting out with a common log. My common log is always base 10. So I'm going to measure the intensity, and here is the intensity on the table. So we start in Peru, which is 8.1, so I got 8.1. And then I got in Mexico 7.6, so we're going to go minus 7.6. So I end up with, the difference here is 0.5. Now I'm going to take this and change it. I had to exponential, so I have 10 to the 0.5 power, what equals my difference intensities. So that comes out to 3.16, so I put it in a sentence because I had a word problem here. In problem number 9, I am going to graph this log function, but it's much easier if I take this and change it to exponential. So 2 to the y power equals x. So here's my x, and here's my y. So I am going to pick values for y instead. So 2 to the negative 1 power is half. So I got half, which is y. I got negative 1. And then I'm going to pick 0 for my y. 2 to the 0 power is 1, so I get 1, 0. And then I'm going to pick 1 for my y value. 2 to the first power is 2, so I end up with 2, 1. 2, 1 right here. And look, this is the shape of a log, because remember, logs are inverses of exponential functions. And it won't cross the y-axis unless there's some transformation. In problem number 10, we're going to graph a log and its inverse. So first I'm going to take my log. I'm going to make an exponential function because it's easier to graph. So 6 to the y power equals x. Now I'm going to pick values of y. If I pick negative 1, I get 6 and negative 1, I get 1, 6. That's my first ordered pair. To do the inverse, I'm going to switch them around. And I'm going to pick 0. 6 to the 0 power is 1. So I got 1, 0. Switch them around to get the inverse. Then I'm going to do the same thing. I'm going to put 1 in. So 6 to the first power is 6, so I get 6, 1. So make a graph. So I graph my points, and you could see here's my exponential growth, and here's my log. They're inverses of each other. In problem number 3, I am going to graph this log and then do my transformations. But first, I'm going to start with the parent function. It's the most basic function. I have a common log here. That means my base is 10. So y equals log base 10 of x. And I'm going to take this parent function and I'm going to switch it around to make it exponential. So I have 10 to the y power equals x. Now I'm going to pick easy values here for y. I'm going to plug in 0 and I get 1. So I have 1, 0. So when I plug in 1, when I plug in 0 for y, I get 1. And then I'm going to go ahead and do that for my other points. So I plug in negative 1, and I got 1/10 right here. And then I plugged in 1, and I got 10. So here's my points. Now my transformation on my x value, what makes a 0 is negative 3. So 1/10 minus 3 is negative 9/10. 1 minus 3 is negative 2. 10 minus 3 is 7. Now for my y values, it says minus 7. That's going to bring the whole thing down. So negative 1 minus 7 is negative 8. 0 minus 7, negative 7. 1 minus 7, negative 6.